reminding me I wasn't recording. So yeah, so if we're doing section 7.1 here, polar coordinates, so we're used to graphing in the Cartesian coordinates. So if I graph the point 1, 1, I go out 1 on the x and then up 1 on the y. What we're going to do today is there's another way to actually refer to that point. And the other way to refer to that point is we can think of that point as sitting on a circle, right? So this point here sits on a circle of a certain, oops, that was a terrible line, of a certain radius and some angle, theta, right? So you can think about basically what we're doing is we're kind of going out some radius, and then I'm rotating to get up to this point, right? In terms of this particular picture, if I were to make a triangle here, this side here is 1, this side here is 1, and so we know that if I have a triangle where this side is 1, this side is 1, that is one of our special right triangles. It's a 45, 45, 90 triangle, and the sides are 1, 1, root 2. So this point here, the 1, 1, that's the x and the y. We can write it as x, y. It's 1, 1. Or, so that's the Cartesian way of writing it. That's what we're used to writing it as. But now we can write it in polar. And polar, we're going to write it as an r followed by some angle theta that we're rotating. So in this case, our r is square root of 2. And the angle we rotated through was 45 degrees, or so we could write it as 45 degrees, or more often we write it as root 2 and then in radians, pi over 4. So 1, 1 and root 2, pi over 4 in terms of polar are the exact same angle, or the exact same point. We're talking about the same point. Questions? No. Okay, so there's a set of equations that will help us kind of go back and forth between Cartesian and polar coordinates. So I'm going to go through them. I'm going to go through where they come from first, and then we'll actually use them. Okay, so the equations used in polar coordinates. So kind of if we look at a generic example of kind of what I just did, right? So here I had this point, we said it was x, y. So I could, just like before, make a right triangle, and this is my angle theta, and this is that r. And if my point here is x, y, I've gone out this far x and gone up this amount of y, which means this side here is x and this side here is y. And so one of the things that we can use is we can use the Pythagorean Theorem, right? That says that x squared plus y squared equals r squared. So because I have a right triangle. I can also find some of the trig equations dealing with theta. So for instance, what would the sine of theta be? Yeah, y over r. And if I wanted to, I could multiply the r up onto both sides and get that r sine theta equals y. I can do a similar thing with the cosine of theta. So what's the cosine of theta? x over r. So again, I can multiply both sides up by r and get that x is equal to r cosine theta. And then I can also figure out what the tangent of theta is. So the tangent of theta would be what? Yeah, y over x. Okay, so all of these equations, we kind of usually boil it down. We take certain representations of them are a little more helpful than others. So the main equations we use are x squared plus y squared equals r squared. Y is equal to r sine theta. X is equal to r cosine theta. And the tangent of theta is equal to y over x. Questions? Okay, so then let's try some problems here. So, plot the following polar coordinates. Oh, yep, I totally can go back. Sorry, I didn't see that. Let me know when you're ready for me to go forward. No problem. Anybody else need me to wait? No? Okay. So, we're going to plot the following polar coordinates. So, A, 3, negative 4 pi over 3. Okay. So, this is where I feel like being online is not the greatest in the world, because I usually bring in string and kind of show these on the blackboard, but we're going to try our best here. So I'm going to go out. Okay, I should also say that Alex, when you're graphing polar coordinates on Alex makes it much, much nicer. And I'll pull up Alex here in a second and show you that. But, so the idea is you first want to go out what your radius is. So our radius is 3. So if I start here at the center, I'm going to go out to 3. And now the idea is I'm going to rotate. And I want to rotate minus 4 pi over 3. So minus 4 pi over 3, if I'm rotating, would get me rotating someplace in here. Right? So my point is going to be someplace up here where this distance here, the radius is 3, and then this angle that I went this way is minus 4 pi over 3. If I did, here's another one. I probably should have done this one first. 2, pi over 4, right? So if I go out a distance, I'm going to go out a distance of 2, and then I'm going to rotate pi over 4. So we're talking about someplace kind of right about there. So right? This is 2, and this distance we rotated is pi over 4. C, oops, I guess I should have written what it is. So negative 4 comma pi over 4. So negative 4, I'm going to go out to negative 4 here, but then I'm still going to rotate pi over 4. So pi over 4 is 45 degrees. So we're rotating positively, so you're coming down in here. So again, this part here is negative 4, and then I've rotated this much, which is pi over 4. So it's just to kind of get you used to the idea that you're going out a distance and then you're rotating. Questions? No? So the radius is whatever this first part is. That's the radius. What quadrant it's going to is you have to think about rotating it. So let me pull up here. Let me actually. When we're going to convert back and forth, we need to keep in mind those equations that we had before, right? So I'm going to kind of write them up here in the corner. So we have x squared plus y squared equals r squared. We have x is equal to r cosine theta, y is equal to r sine theta, and the tangent of theta is equal to y over x. So my first problems here are convert the following points to polar. So A, 2 comma minus 2. And sometimes I think when you're going from Cartesian to polar, it's helpful to graph the point. So here I am at 2, negative 2. So we're talking about this point here. Right, so we're in that third quadrant. So we're going to use I have the 2 and the negative 2. This is my x and this is my y, right? So we're looking for, I'm going to use that first equation, the x squared plus y squared equals r squared, to help me figure out what r is. So we're going to have 2 squared plus negative 2 squared equals r squared. So 8 is going to be equal to r squared. So r is going to be square root of 8. So you could use plus or minus the square root of 8. I'm going to pick the positive one to make my life a little easier. So we're going to have r is the square root of 8. If you use negative square root of 8, then you would have to change the angle that you're using, which is fine. So you could use either one, but I think it's easier to just use the positive one. And then what I need to do is I need to use the equation that the tangent of theta is equal to y over x. So the tangent of theta is equal to y over x, so negative 2 over 2. So the tangent of theta is equal to negative 1. So now you want to think about, on your unit circle, where is the tangent of theta equal to negative 1? So I'm using tangent, right, because these are the, so if you go back here to where we came from, so you can, so the equation came from here, but if you're asking why did I pick the tangent rather than these other ones, I picked the tangent because I'm trying to find theta, and so this tangent equation, it only has a theta in it, so I don't have to worry about the r. If I picked one of these other equations, I'm going to have to use this r, which is the square root of 8, and I kind of like to avoid doing that. I picked the positive square root of 8. You could have picked the negative square root of 8, but then if you pick the negative square root of 8, you're going to have to adjust your angle oddly. So if I have a choice, I always pick the positive r, because then I can just use the values off the unit circle for the angle. Otherwise, if I pick the negative one, now I got to think about adjusting when I swing, I'm not just swinging to I can't just take the value off the unit circle. So if you make r positive, then you can just pick your theta off of the unit circle. Does that help? Okay, and then John gave us the answer here. So I'm looking for when the tangent of theta is equal to -1, and I know I need to be down here in quadrant 4. So if you read that off of the unit circle, the theta ends up being 7 pi over 4. So my point is -1 comma 7 pi over 4. Right, because I was looking for when is the tangent equal to -1, and I need something that's in the 4th quadrant here, right, because that's where my point is living. Questions? You could have picked minus pi over 4. So the thing is where in Cartesian coordinates, there's only one way to write this point, right? If we were writing this point as x comma y, it's always going to be 2 comma -2 no matter what. You could have, oops, and why did I put -1? You guys let me put -1. We want our r value, right, which was square root of 8. So there's a lot of actually different ways you could have written this. So you could have written this as square root of 8 comma 7 pi over 4. You could have written it as square root of 8 comma minus pi over 4. That would get us to the exact same place. We could have also written it as with a negative square root of 8. But if you're doing a negative square root of 8, you would be out here and you have to rotate to this point. So you're rotating 1, 2, 3 pi over 4s. So you could have done that. That's why I don't necessarily like to take the minus square root of 8, because then I have to figure that out. You also could have written it as minus square root of 8 comma negative 5 pi over 4. So there's a lot of different ways that you could write the exact same point in polar coordinates. Oftentimes, and Alex will say this, they'll be like, write it with a positive r and a positive angle. But otherwise, if they don't tell you how you have to write it, you could use any one of those 4. Other questions? Or does that help? No problem. Other questions? No? Okay, so let's try another one. Minus 2 square root of 3 comma minus 2. Right? So again, just so I can think about what quadrant I'm dealing with, minus 2 square root of 3 would be, I would go to the left here and then down minus 2. So we're talking about some point sitting here in quadrant 3, right? And so again, x squared plus y squared equals r squared. So minus 2 square root of 3 squared plus minus 2 squared equals r squared. So this is going to be 4 times 3 plus 4 equals r squared. So 12 and 4 is 16. So 16 is equal to r squared. So we're going to let r be the positive square root of 16. So r is going to end up being 4. Questions? So I found the radius by plugging in here into this x squared plus y squared equals r squared, right? So this is, remember, these were Cartesian points they gave us. So this isn't my x and this is my y. So I plug in x squared plus y squared equals r squared, and then I solve that to get r. You mean the x point. What do you mean the x point? Oh, that was given to me. Like it's stated. That's part of like the statement of the problem. Like we're still in this like convert the following point to polar. So convert the following point to polar, and then I tell you that point is minus 2 root 3, comma, minus 2. Does that make sense? It's like, it's stated. It's you're not finding it. This is like this is given to you. Are you asking how did I know it was down here? How did I know the point was down here? Okay. So all I know is I just know that I know the point is down here because if I'm graphing something and it's negative on the x, I'm going to go this way, and negative on the y, I'm going to go down, right? So I'm going to go to the left if it's negative for the x, and I'm going to go down if it's negative for the y. So I don't know that's exactly at this part. I just know that, I just know that I went some distance here, which is minus 2 root 3, and then I went down here, which is minus 2. Does that help? No problem. Because I don't care about getting the point exact. The problem didn't ask me to plot the point. It just asked me to find what the representation in polar was. So I just kind of need to know what quadrant it's in for when I solve the tangent part. Okay, good. So now we're going to do that the tangent of theta is equal to y over x. So in our case, the tangent of theta is equal to minus 2 over minus 2 root 3. Or the tangent of theta is equal to 1 over root 3. So now I want to know, well, where in quadrant 3 is the tangent equal to 1 over root 3? So 7 pi over 6, right? So theta is going to be 7 pi over 6. So our point here is going to be our r value, r, comma, our angle, 7 pi over 6. Questions? Okay, does anybody need me to wait before I go to the next page? No? Okay. So now we're going to go the other way. So we're going to convert the following polar points to either rectangular. You might sometimes see Alex write rectangular or Cartesian. So either one, and they're talking about the same thing. So A is negative 3, comma, 5 pi over 4. And let me just, go back here and grab these equations here.
We win some of the game.
Okay. So, okay. So going from polar points to rectangular is actually much easier. So if you notice, we have these two equations right here, x equals r cosine theta and y equals r sine theta. And those two equations will actually will give us exactly what x and y are. So remember, this is my r and this is my theta. So x is equal to r, so negative 3 cosine 5 pi over 4. And if I work out what that is, so I have negative 3, the cosine of 5 pi over 4 is what? Close. It's not quite root 2 over 2, but it's close. It's got root 2 over 2 in it. Yeah, it's minus root 2 over 2. So minus 3 times minus root 2 over 2. So we end up with 3 root 2 over 2. And then y is going to be equal to r sine theta, so minus 3 sine 5 pi over 4. So this is going to be minus 3. What's the sine of 5 pi over 4? Yep, it's also minus root 2 over 2. So this is also going to be 3 root 2 over 2. So our point is going to be 3 root 2 over 2, comma, 3 root 2 over 2. Questions? So we'll try another one. B 2 comma minus 11 pi over 6. Yeah, this is way easier. To go from polar to Cartesian is way easier when you're just dealing with a point. The next thing we're going to do is we're going to convert equations. And if you're converting from Cartesian to polar in terms of an equation, then it's easier to do it that way. And then the harder way is to go from polar back to Cartesian. So x here is going to be 2 cosine minus 11 pi over 6. And so what's the cosine of minus 11 pi over 6? Yep, root 3 over 2. So 2 times root 3 over 2. Ooh, see, that's just going to be root 3. And then y is going to be 2 sine minus 11 pi over 6. So it's going to be 2 times, what's the sine of minus 11 pi over 6? Yep, 1/2. So this is going to be 1. So this is the point root 3, comma 1. Questions? So you might be going like, why do we care about this? So basically, there's two things here. One, the reason we do it in trig is because you can see it's using trig values, or it's using trig functions. So it's an application of trigonometry. So that's one of the reasons why we do this in trig. And then secondly, why do we care? Well, the thing is that if you were to go on and take calculus 2, or not calculus 2, calculus 3. So if you have to go on and go up to calc 3, there are problems that are easier to do in polar coordinates than they are in rectangular coordinates. So in calc 3, we do a lot of, because we're dealing with three-dimensional space, so we use polar coordinates and another type of coordinates called spherical coordinates. And they actually make things way easier to deal with than regular x and y coordinates. So that's kind of why. So this is a skill, like, you know, if you're going on to calc 1 and you get to stop after calc 1, you're never really going to encounter polar coordinates again. But if you do have to go up to calc 2 or calc 3, we do a little tiny bit with it in calc 2, but then we do a lot of it in calc 3. Okay, so the last thing we're going to do is we're going to work on changing equations back and forth. So, convert the following equations to polar. Okay, so when we're converting equations to polar, our goal is the following. So, get rid of r and theta by changing to, not get rid of r and theta, get rid of x and y by changing to r and thetas. And then, if possible, solve for r. So, a lot of times when we're dealing with writing a polar equation, we kind of like to write it as r equals this. Kind of just like when we have the equations we're usually used to working with, we oftentimes solve them for y. We don't always solve them for y, but a lot of times we solve them for y. So it's the same thing in polar. A lot of the times we solve the equations for r if it's possible, if we can do it. So the first one here, x squared plus y squared plus 6x equals 0. And again, I said going from rectangular equations to polar equations is actually the easy one. Even though going from rectangular points to polar points was not the easy way, going from rectangular equations to polar equations is actually the easy way. Because remember, x is the same as r cosine theta, and y is the same as r sine theta. So this is going to be r cosine theta quantity squared plus r sine theta quantity squared plus 6r cosine theta is all going to be equal to 0. And then I have to kind of work out what some of this stuff is. So r cosine theta quantity squared is r squared cosine squared theta. And r sine theta quantity squared is r squared sine squared theta plus 6r cosine theta. You could have also at the beginning said, oh, look, I know that x squared plus y squared is r squared. So we could have said this was just r squared plus 6r cosine theta. So you can do that. That's not a problem. We're going to get to the exact same place here. In the first two pieces, I could factor out an r squared, and I'd have r squared times cosine squared theta plus sine squared theta plus 6r cosine theta. And if you remember from when we were doing identities, cosine squared plus sine squared is 1. So this is saying r squared times 1 plus 6r cosine theta equals 0. Or r squared plus 6r cosine theta equals 0. So you could have jumped right from this first line to this line if you use the x squared plus y squared equals r squared. So that is technically like a final answer. However, in this one, I could actually do a little bit more work and try to solve for r itself. So to do that, you notice both terms here have an r in it, so I could factor an r out. So I'd have r times r plus 6 cosine theta equals 0. Oops. I put that parenthesis in the wrong place. And then I have two things being multiplied to give me 0. So either r equals 0 or r plus 6 cosine theta equals 0. And the second one, I can say r is equal to minus 6 cosine theta. So you actually end up with two different answers here, that r could be equal to 0 or r could be equal to minus 6 cosine theta. You could just stop at the r squared plus 6r cosine theta equals 0. I just can't remember if Alex will take that or not. It might make you go down all the way like I did. Questions? Yep, x squared plus y squared is always r squared. Yep, so that's one of those, I wonder if I can still, yep, so it's one of those original equations, right, that we worked with. So, yes, these will be on the final exam, problems like this. And where could you stop? So I'm okay if you stopped. You could stop here. But like, so for me, for a test, you could stop there. I think Alex is going to make you go all the way down here. Questions? No? Okay. So let's try another one here. 3x plus 2y equals 6. And let me again put these equations here. So again, we're just plugging in. So we have 3x is r cosine theta. So 3r cosine theta plus 2r sine theta equals 6. And again, you want to, if possible, solve for r. So in this case, I can solve for r if I factor in r out. So I have r times 3 cosine theta plus 2 sine theta equals 6. And then I could divide both sides by 3 cosine theta plus 2 sine theta. 3 cosine theta plus 2 sine theta. So r is going to be equal to 6 divided by 3 cosine theta plus 2 sine theta. Questions? No? Okay, so that's the easier way. The other way isn't so much harder. It's just, it does take sometimes a little bit more work. So let's try another example here, or let's look at them. So we're going to convert the following to rectangular. And so again, here's these equations. So when we're trying to convert to rectangular, we're trying to get rid of all the r's and thetas. So the only things I want left are x's and y's. So the first one here is going to be r cosine theta equals -4. So these you kind of have to look, each individual problem is going to have a little bit of a different technique to use to it. Remember, we're trying to get rid of the r's and the cosine thetas, or the theta. R theta happens to be with a cosine theta. But if you look, r cosine theta, we do happen to know what r cosine theta is. So what is r cosine theta? Yeah, r cosine theta happens to be x. So this is just equal to x equals -4. And I can stop because I've gotten rid of all the r's and thetas. And remember, x equals -4 is a vertical line, right? So this is a vertical line. And that kind of makes sense, right? So you have this r cosine theta, since we said it's just, and it's equal to just this number. So, and that r cosine theta is x. So I just have x equals that number. B, theta equals 5 pi over 4. Okay, so I somehow need to get rid of theta. And theta is the only thing I have. So if you look over at my equations over here, are there any of those equations that just have a theta in it and no r's? Yeah, so we're going to use that tangent one. So we know that the tangent of theta is equal to y over x. So in our case, the tangent of 5 pi over 4 is equal to y over x. And then, yep, the tangent of 5 pi over 4 is 1. So 1 is equal to y over x. And if I solve this for y, if I multiply up, I'd get x equals y. Right? You could write it if you want with the y on the left-hand side, y equals x. And so what type of a graph is y equals x? Okay, it's a diagonal what? Yeah, it's a diagonal line. So this is a line. So anytime you have, all you're given is an angle, theta, in terms of polar coordinates, you're really just dealing with a line. So if you just have theta equals some number, you're basically just talking about a straight line. Questions so far? So remember I'm talking about, so it's basically back from like pre-calc 1, or math 95. So anytime you have x equals a number, right? So like here I am at negative 4, 2, 3, 4. You're talking about x is always equal to negative 4. So no matter what y is, so we're going all the way up this way and all the way down this way. So anytime you have x equals a number, you're talking about a vertical line. Y equals a number, you're talking about a horizontal line. I know, it's like pulling in, now we're beginning to pull in kind of like stuff from a bunch of the other classes. Other questions? Why did we solve for y? So I solved for y just because we're usually used to, if you think about it, most of our equations, anytime we have equations, we try to solve them for y if we can. So that's why I solved for y. You could have easily solved for x. In this case, it happens to be the same thing, right? Does that answer your question? Other questions? No? Okay, so I have a couple more here. So C R equals 5. And again, remember these are the equations that we're using. Okay, so I have R equals 5. Do we see, in looking at our equations, do we see any equations that this time just use R and have X and Y? And that don't have a theta, right? Because they didn't give me a theta. My problem doesn't have a theta in it. So is there, yeah, the first one, the x squared plus y squared equals r squared. So x squared plus y squared equals r squared. So if I plug into that, I have x squared plus y squared equals r squared. So 5 squared. So x squared plus y squared equals 25. And so because the y is squared, I'm not going to solve for it. I'm just going to leave it like that. But does anybody remember from Math 126 what type of shape that is? Well, you don't see any writing. Anybody else? Did I freeze for everybody else too? Oh, okay. Good. Oh. Sorry. Yeah, it was laggy for a little while, I know, but then it seemed like it was doing okay. But if I start writing again and you guys can't see it, let me know and I'll disconnect and reconnect the iPad again. So yeah, so all I did, right, was plug in the 5 for the R, and I get that x squared plus y squared equals 25. And then, yes, it makes a circle. So this one tells us it's a circle. So can you guys see that I wrote the word circle? So let's try a couple more here. D, r is equal to negative 2 sine theta. Okay, so this problem, r equals negative 2 sine theta. I have an r and I have a theta, so it's going to take a little more work for us to figure out what's going on. If I happen to have over here r sine theta, then I could have used this line here that says x is equal to r cosine theta. This line here that says y is equal to r sine theta. The problem is I don't have an r in here, right? I have a negative 2, but I don't have an r. So one of the things that I can do, and that a lot of times you sometimes have to do in these problems when you're trying to convert, is you actually have to multiply both sides of the equation by something to try to get some stuff to work with. So I could multiply both the left side, so I'd have r times r, and then here I can multiply this side, so r times minus 2 sine theta. So I haven't changed my problem at all, right? Because I've done the exact same thing to both sides. The only difference here is that now I have a little bit more to work with. So on the left-hand side, r times r is r squared, and on the right-hand side, I could rewrite this as minus 2r sine theta. So I'm doing it because basically the reason I'm multiplying by r is because I want, if I'm trying to convert and I have a sine theta or I have a cosine theta, I want that sine or cosine theta to have an r multiplied by it, right? Because then I can say, oh, r sine theta is the same as y, or r cosine theta is the same as x. So there wasn't an r in here with the sine. So basically I want to multiply this side by r. But since I multiply this side by r, I have to do the same thing to the left-hand side. And then it actually happens to help out my left-hand side as well, right? Because now my left-hand side is r squared. And so we know that r squared is, by the first equation, x squared plus y squared. And now I have minus 2, and then r sine theta is y. And if you wanted to, you could stop there. You could move the minus 2y over and get x squared plus y squared plus 2y equals 0. And anybody know what that is? Yeah, so I know why you would say ellipse. So we actually haven't talked about ellipses yet. We are going to actually talk about conic sections. So we're going to talk about, besides circles, we're going to talk about ellipses and hyperbolas, and then parabolas, which we've also seen before. We are going to talk about them at the end of the semester. But right now, what we actually have is that these, so this is actually still a circle. It's just that the plus 2y changes the center of the circle from being at 0, 0, right? It moves it over. So this is also still a circle. So anytime you have x squared and y squared, and the number in front of the x and the y, the x squared and the y squared is exactly the same. So in our case, 1 and 1, it's always going to be a circle then. Other questions? Okay, so then I can't remember, like on the final exam, there might be problems where you have to convert stuff. There's a problem that I always give on the final exam that asks you to identify what conic section it is. So is it a circle, a parabola, an ellipse, or a hyperbola. So we do all the conic sections. I can't remember if on Alex it asks you to say what it is. It may not, but that's why I was kind of just going over it in case it does. No problem. Okay, so my last problem here, we'll fit it here, E. R equals secant of theta. All right, so the problem is the secant of theta is not in any of those original equations that we have up there, the 4 that we've been using to convert. So who remembers something about secant of theta, though, that might help us out here? Yeah, secant is 1 over cosine. So R is going to be equal to 1 over the cosine of theta. And so then I'm going to multiply the cosine of theta up. So I'm going to get R cosine theta equals 1. And then R cosine theta, we know, is x. So this is just x equals 1. So this is another vertical line. Questions? No. Does anybody need me? What I want to do in the last couple minutes here is I actually want to share my screen again and show you about the review for or not the review for the test, the take-home test, so the next test. So does anybody need me to wait before I share my screen again and then make this writing part disappear? No? Okay. So let me do that. Okay. So in our Canvas page, right, and I'll go into student view here so it looks like yours. Okay. So if you go here to assignments, right, you will see that down here there is, oops, where did it go to? So upcoming assignments, test 3, right? So if you click on test 3, you'll see it says click here for the test, right? So I can preview it. It should show it here. So this is the test, right? You can access the test. Basically what you want to do is you want to so you're going to do the test, right? You can see the test has 4 questions, although part 1 has 7 parts to it. So the test is due 1 week from today. So it is due on Wednesday, April 21st by 4 p.m. So you have to have it uploaded into Canvas by 4 p.m. And so you can take it anytime you want. You don't have to take it like all at once. It's not like a test like that's proctored in class where you have to like do the whole test then. So you can, you can work on it. You could print off a copy. You could look at it. You could start working on it today. Do a little bit every day. It just has to be up by next Wednesday at 4 p.m. And so the kind of the rules for the test are that it's a take-home test and that you have to do all of the problems by yourself. Okay. So you're allowed to like look at your notes, look at videos, look, you cannot ask another living, like, human being for help with this test. So whether that's a friend, a tutor, any other, like, human living person that you would be interacting with either online or in person, you can't get that kind of help for the test. And so basically, the first thing you want to write at the top of your test paper when you turn it in is I, and then write your name. Agree that I have abided by the rules of this take-home test. So you are basically, you need to put that on your paper so that, like, I know that you knew what the rules were and that you followed the rules. Questions? No? Okay. So if you don't have any questions, then that's kind of all I wanted to do today. And I will see you guys all next time when we'll actually learn about vectors. Haha, yeah. You can figure out the measurement of the tree. That's what the problem is asking you to do, right? I think that's what it's asking you to do. It's been a while now since I typed it. Isn't it? Oops. Right? Yeah. How tall is the tree? That's for you to figure out. But nice try. No problem. You have a good weekend too.